Hello and welcome back to another video series. In this video series, we are going to discuss and give some example of what is a parallel and a serial transmission. And when we talk about the parallel and a serial transmission in digital system, we are mostly talking about sending what is called a data. And we all know that data carry the information, and this information is in terms of the binary, and binary is consist of ones and the zeros. The important thing about a data transmission is that we are transferring this data from one device to another device. Example, we say device 1, and this device 1 has some information, and we want to transfer this information to another device called device 2. In order to send the data, which is the word such as hello, and this hello is a data, and in digital system it is represented by a binary. And to transmit this data to device 2, we now have to look at the type of transmission, and this transmission is now can be regarded as a parallel data transmission or serial data transmission. And in this video, we are going to look at the type of transmission called the wired transmission. When we talk about the wires, we are actually looking at a physical component such as a copper wire that is used to transmit information. And also we have the wireless transmission of data, where the data is transmitted through a free space. And also we normally use the fiber optic cable, which is really fast and is convenient for high-speed data transmission. When we discuss about the speed, we are going to look at the type of medium in which the data can be transmitted. And currently, fiber optic is much faster than the wired medium. And our main purpose is to transmit this information such as hello to appear at device 2. And also we can have the n number of devices that we can connect, and we can use either parallel or serial transmission to transmit this data to other devices. And some of these devices, they can either send and receive. So we have a two-way communication model, where device 1 can transmit data and it can receive data, same as for device 2 and so on. And when device 1 is sending out information, it is regarded as a transmitter. And if it is sending to device 2, the device 2 is regarded as a receiver. Similarly, if device 2 wants to send information to device 1, it can be regarded as a transmitter, and device 1 can be regarded as a receiver. So in most devices, a circuit made up of a transmitter or a receiver is built to facilitate this type of transmission. Now we are going to look at what is really a parallel transmission and a serial transmission. To simply understand what is a parallel transmission, we know that information is transmitted from one device to another. And when we say parallel transmission, we can be able to say that we have multiple output and multiple input of a transmitter and a receiver respectively. That means information is sent from one device to another device via multiple lines. And when we look at a serial transmission, we can be able to see that we have only one output and it is consist of only a single line, and data is transmitted using a serial transmission. The important thing is the clock. Data is sent through a single line, one at a time. And I will also give you example for you to clearly understand the difference between the two. And we can say in a parallel transmission, we can say multiple data is transmitted at once, and in a serial transmission we can be able to say that a single data is transmitted one at a time. And when we talk about the parallel transmission, we can have multiple input and we can have multiple output, and I will explain this. And in a single data transmission, we have a single input and we have the single output. And when we talk about the receiver and the transmitter, we can clearly see that when we have the multiple input, this particular device is a receiver. And when we talk about a device having multiple output, which is the transmitter. Same as for a serial transmission, a device having single input is the receiver, and the one that is having a single output is the transmitter. And this can be able to give you an idea of what we mean by a parallel transmission and a serial transmission. And now I will give you a graphical explanation to what is a parallel transmission of data and the serial transmission of data. The main idea between the parallel and the serial transmission is all to do with the information that is represented in a digital system known as a data. Now we have the device 1. And this device 1 is now acting as a transmitter. And we have the device 2, which act as a receiver. And now from the definition, we say that in a parallel transmission, we have multiple data that is transmitted at once. That means we have the transmitter will have multiple input and the receiver will have multiple input as well. And from there we can see that now we can have multiple data lines, and this data line is responsible for transmitting the data one at a time. And if we can be able to look at a graphical representation, and we have what is called the time. And now if we have 4 data lines, that means we can have the signal 1, signal 2, signal 3 and signal 4. And this graph will represent signal 1, and we can also have this one 1, 2, 3, 4, and this can represent signal 2, and we can also have 1, 2, 3, 4, which can also represent the signal 3, and finally we can be able to say that we have 1, 2, 3, 4, and we have time, and this represents signal 4. Now from this graph, if we say that the data needs to be transmitted at once, and this once is representing the time, and this time is represented by the horizontal axis. Let's say 1 second, 2 seconds, 3 seconds, 4 seconds, and etc. As time goes by, for each of this interval, data will be transmitted. And if we now have to transmit, for example, 1, 0, 1, 0, and we can be able to see that from this graph, we can now have 1, and this will be 0, and we have another 1, and this will be 0. That means for this time interval, this data we have 1, 0, 1, 0 will be transmitted from device 1, which is the transmitter, to the receiver. And what will happen for the next time interval? Now if we have 1, 0, 1, 0, if we are to put it this way, we can be able to say for t is equals to 1 second. Now if we have 1, 1, 0, 0, that means for this time interval, we now can say t is equals to 2. Now we can have 1, 1, 0, 0, and we can plot the graph such that we have 1, and this will be 1, and this will be 0, and this will be 0, and we assume that the data is transmitted in this direction. And if we now have another data such as 0, 0, 1, 0, now we can have the time equals 3 seconds. We now can have 0, 0, and we can have 1, and we can have 0, and then we can be able to say 0, 0, 1, and 0, and we assume data is moving in this direction. And we can also say in the 4th seconds, if we have 1, 1, 1, 1, now we can have all the 1s. So we have 1, 1, 1, 1. And from there we can say we have 1, we have 1, and we have 1, and finally we have the 1. And now this represents the information, and this will be the information transmitted at once. This will be the information that is also transmitted one, but in different time interval. And same as for the data 3 at the interval 3 and data 4 at the interval t is equals to 4 seconds. And you can see that this represents the flow of data. And from the graph, it is in the backwards direction. When time equals to 1, time equals to 2, time equals to 3, and time equals to 4. That means those data are available to be transmitted from device 1 to device 2. And If this is the transmitter that is transmitting this data, now we can have the receiver, and the receiver can now be able to accept the data. Let's draw the graph again, and we can say for t is equals to 1, t is equals to 2, t is equals to 3, and t is equals to 4. And in the phase time intervals, that means this is the receiver. So this represents the phase set of data that will be transmitted. So in that case, the receiver will now be able to receive the data such that 1, 0, 1, 0, and in the second time interval, it will be 1, 1, 0, 0, and the time interval t is equals to 3 seconds, we can have 0, 0, 1, 0, and finally 1, 1, 1, 1. So from this graph, we can be able to see that this data represent what is called the receiver, and the data that will appear at the receiver end will be in this manner. And we all know that the data from the transmitter will be in this direction, and the data that is received from the receiver will be plotted in this direction. And we can be able to clearly see that this represents the signal line 1, this graph represents the signal line 2, this graph represents the signal line 3, and finally this graph represents the signal line 4. So data is transmitted at once at each time interval. And I believe you should be able to clearly understand how this data transmission, such as the parallel transmission of data, really works. And imagine that you have a computer, and this is your computer, such as a laptop, and you have a printer, and this is your printer where you will print some information. And now this computer is connected to the printer via a parallel transmission cable. And now those data, if you want to print a letter, and when you save this letter in a computer, this letter contain information will be stored in terms of the binary. And when you want to print this data, all this binary information which is on your computer, which is exactly in a Microsoft Office Word or a PDF form, all of them is represented in terms of the binary. And the same binary containing the same information will be transmitted via this parallel transmission cable. And therefore, this printer will be able to receive the exact information that is represented in binary from your letter that is typed and saved as a Microsoft Office Word or a PDF. And now, when this information is present in your printer, it will now convert this type of information, a letter, into a printable format. And when you print, you will have the exact same information, or the information from your letter will be printed out for you. That is why you can be able to see the importance of how this system operates, especially digital system, because everything that is stored in your computer and transmitted to the printer via a cable is now be able to transmit this binary information to another device, because a computer is device 1 and it cannot be able to print information, while a printer is a device 2, while it has the capability to print information. But in order to transfer information from your computer to a printer, which the printer can be able to print, you need a transmission. And now with this transmission, such as a parallel transmission, you can be able to transfer this exact information to your printer, and now your printer can be able to print your document. Thank you for watching our video. Kindly subscribe to our channel and share this video with your friends so they can also be able to learn.